beginning our descent towards Amsterdam Schiphol
You'll have to
Airport.
turn that off, Vanessa. Thank you.
Turkish Airlines Flight 1951 is preparing to land in Amsterdam.
Amsterdam, Turkish 1951, descending to 7,000, speed 250.
The crew is flying a state-of-the-art Boeing 737.
Flaps 15.
Localizer alive, localizer captured.
In the final moments of the flight, the landing turns into a catastrophe. According to the passengers, the landing had been routine, but then suddenly the plane simply dropped out of the sky and hit the ground. But perhaps the biggest clue comes from the crash site itself. The wreckage is not spread out. It tells investigators that the plane could not have been traveling forward at high speed when it hit the ground. The pattern of debris and the passenger reports point investigators to an immediate suspect: the engines.
The engines issue was a very big issue in my thought process at the time, initially.
There's no evidence of fire on the fuselage. In many crashes, fuel in the plane's tanks ignites on impact. The lack of fire raises an obvious question. Did the engines stop running because Flight 1951 had simply run out of gas? But the location and condition of the plane's engines suggest that perhaps they didn't quit in flight.
Sure looks like it was running.
When we first looked at where the engines ended up, the initial impression was that they probably were producing thrust at impact, given that they were so far forward of the main wreckage. That was just a very general conclusion.
Only the flight data recorder can tell investigators how much power the engines were generating in the seconds before the crash.
Lots of fuel. Rules that out.
It doesn't take long to discover that there was plenty of fuel in the plane's tanks. Flight 1951 definitely did not run out of gas. Passengers report that in the final seconds before the crash, the plane hit what felt like turbulence. It points investigators to a well-known culprit, a microburst. A microburst is a powerful column of air that shoots out of storm clouds. It can literally slam a low-flying plane to the ground. Investigators learned that there were heavy clouds above the airport at the time of the accident. A powerful gust of wind may well have accompanied them. The flight data recorder will have recorded wind speeds outside the plane. Investigators will need to analyze the flight data to prove the microburst theory. In the meantime, the rescue has led to an unusual discovery.
There was 3 pilots in the cockpit, which is unusual. This is a 2-crew cockpit. So why was that 3rd pilot there?
The reason for the 3rd pilot is soon uncovered.
Flying standard arrival route. Visibility 3,500 meters, expected to decrease to 2,500 meters.
For First Officer Murat Sezer, this had been a training flight of sorts. He was new to the airline and was being shown the intricacies of landing at Amsterdam's airport. But the voice recorder has picked up an unusual sound, a warning that makes no sense at this stage of the flight.
One of the investigators from Boeing was a engineering pilot that came and helped with the CVR. And he's listening to see when, or are there any unusual sounds that can be heard that would not be normal.
Speed okay for ILS 18 right. Descent 4,000, ILS 18 right.
The alarm keeps sounding. It's the landing gear configuration warning horn. Captain Arasan continually dismisses it. Investigators now turn to the flight data recorder to help solve some of the mystery surrounding this flight. The analysis of wind speeds outside the aircraft is completed. It's clear, none are drastic enough to have brought down the plane.
Evidence of a microburst.
But the flight data recorder does provide some valuable insight into the cause of the landing gear warning. One of the instruments that measures altitude had the plane already on the ground. The Boeing 737 is equipped with 2 separate altimeters. One measures air pressure to determine the plane's height above sea level. That reading is displayed prominently in the cockpit on both pilots' flight display.
0, set, sir.
The plane is also equipped with a radio altimeter. It's made up of 4 antennas. 2 transmit signals to the ground, and 2 others read the signal that bounces back to determine the plane's height. They learned that with Flight 1951 still about 17 kilometers from the airport, controllers directed the pilots to begin their final turn to line up with the runway. It's equipped with an instrument landing system, which sends out a signal outlining the ideal descent path to the foot of the runway. The autopilot follows that glide path until the plane is a few hundred feet from the ground. Then the pilot takes over. It makes landing almost effortless. The crew begins configuring their plane for landing, unfazed by the warning horn that's repeatedly triggered by the malfunctioning radio altimeter.
Flaps 15.
10 kilometers out, Flight 1951 picks up the ILS signal that will guide the plane to the runway.
Localizer alive. Localizer captured.
The safety pilot, Olgay Ozgur, now reminds Captain Arasan about the failed altimeter.
We have radio altimeter failure, sir.
Okay.
Turkish 1951.
Runway 18 right.
Clear to land.
Clear to land. Thank you.
Investigators are stumped. The crew knew about the malfunction and continued their approach. How had it then caused them to crash? Clearly, there was more to this accident than a faulty altimeter. International guidelines call for approaching planes to intercept the signal that guides them to the runway from below. It's so pilots don't have to make any drastic last-minute course corrections to get to it.
To intercept here, they had to descend.
But Flight 1951 was given instructions that brought it to the threshold of the glide slope while still way above it. It's a common practice at Schiphol because it gets planes to the runway faster. Approaching a glide slope from above is more difficult, mostly because the crew has to suddenly slow the plane and descend rapidly to intercept the signal.
We also call this a slam dunk approach, and some pilots like it, some pilots don't. It's a little bit harder, and things happen quicker when you're above the glide path trying to intercept from above. And it's just a challenge for a lot of pilots.
Please warn the cabin crew.
Cabin crew, take your seats.
Then, real trouble. A stall warning.
Speed, sir.
I have control.
100 knots of speed.
Arasan fought to save his plane, but just 400 feet above the ground and only 1.5 kilometers from the runway, the Boeing 737 suddenly fell straight down. It only took a few seconds for it to hit the ground.
Turkish 1951.
The recording sheds light on the final minutes of the flight. The crew was configuring their plane for landing well after it should have been done.
Flaps.
Flaps 40. Green light.
Most airlines have regulations that call for a flight to be stabilized, to have all checklists completed by the time the plane hits 1,000 feet.
Cabin crew.
In fact, this crew was still running their checklist up to the moment the crisis hit, 460 feet above the ground. But the flight data recorder does provide another intriguing clue. Moments before Flight 1951 hit the ground, the plane's engines were at idle, hardly providing any power. Perhaps this accident is a repeat of the Heathrow incident.
That was a big red flag right there. The question is why was that the case?
But then they spot something that's very different from the accident at Heathrow.
Tart flare mode.
For some reason, while still more than 1,000 feet above the ground, the plane's computer began preparing to touch down. In retard flare mode, engine power is reduced to idle by the flight computer, and the plane's nose automatically pitches up to the flare position. Planes should only be in this configuration just before they touch the ground. But Flight 1951 went into a slow, nose-up position well before touchdown. causing the plane to fly slower and slower throughout its descent. So why was Flight 1951 in landing mode? And why hadn't any of the 3 crew members noticed how slowly they were flying? The computer that flies the plane consists of 2 main systems, the autopilot and the autothrottle. The autothrottle determines how much power to ask the engines for, while the autopilot controls the plane's altitude and direction. The 2 systems work independently of each other, and only one of the radio altimeters provides information to the autothrottle. The pieces of the puzzle begin coming together when they find the connection between the faulty radio altimeter and engine power.
The radio altimeter provides information to the autothrottle from the captain's side.
The only altimeter feeding information to the autothrottle was the captain's, and it was wrong. It showed -8 feet throughout most of Flight 1951's approach. The only component that survived the crash checks out. The computers that control the system also work. But investigators do make a curious discovery about them. They aren't the same ones that were installed on the plane when it was delivered to Turkish Airlines 7 years ago. This find changes the focus of the investigation.
Had additional data from Turkish Airlines. And that data showed that on this one aircraft, of the past, I believe, over 1,000 flights, there was about 150 flights that had faulty radio altimeter systems.
The documents show that a little more than a year before the crash, both computers were replaced because of complaints they were causing faulty readings. One of the incidents involved a radio altimeter reading of -8 feet.
So that was telling us that there was an issue that had been there. The issue did not just occur on this flight.
They don't have to dig too far back to find out that in fact it had, on this very same plane.
On 2 recent flights, they had the exact same problem.
Twice in the 48 hours leading up to the accident, the radio altimeter showed a negative reading, putting the plane into retard flare mode. Both times the crew noticed the problem, disengaged the autothrottles, and brought the plane in for a safe landing.
It really got us wondering of what happened. And that's when we started to look really closely at the actions of the flight crews while it was on that final approach in less than 1,000 feet.
Finally, as investigators again revisit the last minutes of Flight 1951, the circumstances of the tragedy become clear. They see a remarkable sequence of events that transpire to bring down this plane.
So, what was happening when the plane went into retard flare mode?
They discover that the plane went into landing mode and pulled back power at the worst possible moment, exactly as the crew was descending to meet the glide slope.
It masked what was actually happening.
As the crew configured their plane to drop down to meet the glide slope, they expected the plane to slow down as part of that maneuver. But the plane was actually slowing down because the computer was in landing mode. That's why none of the 3 pilots said anything about the throttles moving to idle.
It was insidious. Where it first captured in the retard mode, it didn't hurt them at all because they were actually high and they were a little bit fast. And the pilots actually wanted the power back anyway. In fact, the throttles may have already been in the flight idle mode as they were trying to get down and slow down.
In their haste to complete their checklist, none of the 3 crew members noticed the warnings that their speed is dropping dangerously. First, a red bar appeared on their flight display. Then, when the airspeed continued to drop, a flashing box appeared around their actual airspeed to draw the pilot's attention to it. At this point, no one sees either.
Cabin report confirmed.
The aircraft is now 600 feet from landing.
When things start changing colors, it's a warning to you, it's a caution to you that you're approaching the limits of the aircraft.
Missed approach. Altitude set.
500.
So all these indications the crew has in front of them saying that the aircraft is slowing down. During that time, they were still completing their checklist.
Of course, the aircraft is getting closer to the ground.
In fact, it's less than 500 feet from...
They advanced the throttles to full power. It was unrecoverable. They were too low for the engines to catch up.
Boeing also didn't foresee the potentially deadly effect of a faulty altimeter. But on February the 25th, 2009, it triggered an unusual sequence of events that brought down a jetliner and killed 9 people.
Auto throttle to go to a improper mode that is, of course, not a good situation.
The cause of the radio altimeter failure was never uncovered. The Dutch investigation asks Boeing to improve the reliability of the system. But the report also faults the crew for not noticing that their airspeed was dropping dangerously low, in spite of the fact that there were 3 pilots on board.
Who's the ultimate computer? The pilot, the individual who should be able to say, I don't know what this thing is doing to me, but I'm punching it off and flying the airplane. Fly the jet. Probably the smartest thing we ever learned to say in our training in the airlines. Fly the jet. Do that first or nothing else counts. That's what they forgot to do.